guys. Oh, welcome to another beautiful edition of Patio Productions Pre-Calculus Lessons from my backyard. Ladies and gents, today we are going to learn another section from chapter 13. Let's just get started right away. No need to beat around the bush, because I'm in the backyard. Let's go ahead and start this presentation. Here we go. So hopefully you were able to, for the past couple of days, I know math induction was really hard. Hopefully the next lesson that you had yesterday got just a little bit easier. And then now we're going to go back and visit like those sequences again, and we're going to introduce a little bit more complicated notation, definitely something that is very like a precursor to moving into like a calculus course. Okay, so what we're going to talk about is limits of sequences today. Okay, so remember, this is a video. You can pause it at any time. If I'm going too fast or you need to revisit something, you can rewind. So, right, like super fun, super exciting. Okay, so limits of sequences. So we've looked at sequences. We have written them out. We have summed them. And so we know like what to do, like how to just look at them. But now we're going to examine what the sequence terms go to, right? Like, so like what would be like the end target value that we're going towards as the n value, because right, when we do a sequence, we always write it like, a sub n, as that n value gets larger and larger and larger without bound. So let's just consider a sequence kind of like just to like work with before we even introduce some of the notation. So let's say like our sequence was a sub n. Okay, so just a very simple a sub n. And let's write out some of these terms, right? So this is our sequence, and we're saying it's 1 over like plugging in n values starting at 1. So the first number would be a 1 because it'd be 1 over 1. Then we'd have a 1/2, a 1/3, a 1/4, a 1/5, a 1/6. Notice this is a sequence, so we're putting in those commas, and then dot, dot, dot. So what do you think, like these numbers, what are they like heading towards? Like, is there a target value that they're getting close to? Okay, so that's the question we're asking ourselves. What are the terms going to? Well, I mean, I guess the terms are like, I guess getting smaller, because like 1/6 is definitely smaller than 1/2, and I guess like a 1/8 would be smaller than a 1/6. But what are they going to? So I guess they're getting smaller, but what is really happening? Let's maybe examine some bigger numbers just to think about what it's going to. Let's try a to the 10th. A sub 10, excuse me. Whoopsies, said the wrong thing. So a sub 10 is 1 over 10. Which would it be like 0.1? I am kind of choosing some numbers strategically here, like to make sure they can be decimals really nicely. If we tried a sub 100, the 100th term, it would be 1 over 100, which would be 0.01. Okay, I see what you're doing here, Mrs. Fox. What about a sub 10,000? It would 10,000, JK, 100,000. A sub 100,000. It would be 1 over 100,000, which as a decimal would be 0.00001. Okay, if you were thinking about like rounding these numbers like this, like it kind of like could be something. What about this one? What about this one? I feel like these numbers are basically like 0, right? Just 0. So here's the deal. As these numbers, as if you take the sequence of numbers that is 1 over n, you're just making bigger and bigger and bigger numbers for n, and basically 1 divided by a really big number is the same thing as 0, because we're talking about going to like infinity, like huge numbers. So it'd be like 1 divided by 100 million, 1 divided by, like 100 billion. So those numbers just get so ridiculously small that they're practically the same thing as 0. So let's talk about this notation that just popped up on the screen right here. This says the limit. Okay, LIM is the shorthand word, the abbreviation, kind of like, like SIN is abbreviation for sign. So this is the limit, and underneath we say as n approaches infinity. So n arrow infinity symbol stands for as n approaches infinity. We write our sequence of 1 over n, and we are saying that this equals 0. Okay, now here's the deal. There is no term that is 0. It just gets super, super, super close to 0. Okay. If we were to like kind of graph these coordinates, it would almost be like it was asymptotic to the x-axis, right? So again, there is no term that actually is 0, okay? You would always have some sort of number down hanging out at the end of the decimal, but it just gets super close to 0. Okay, to find the limit of a sequence, what we usually have to do is algebraically manipulate it. And so you have to do a little like trying to turn them into things that you know. And so algebraic manipulation is important. A little bit later, I know, just a little bit later, we're going to learn some other like kind of like tricks. But for now, it's not really a trick. It's more like just like an observation. But for now, let's just go ahead and leave it as just the limit of a sequence. Okay, so let's do this. So the limit of a sequence as n increases without bound. So this says a sub n, for part A of this question, a sub n is equal to 2n plus 8 over n. So from the previous slide, I'm going to go backwards just really fast. This is one thing that we know, okay, like 100% for sure. If you take a number, and it actually doesn't even matter what number it is, and you divide by n, as long as n is getting super, super, super big, our answer is going to be 0. We're talking about going to infinity, okay? So what I'm going to do on this one, this example here, is I'm going to try to make some situations where I can get a number over n and try to clean it up. One way to do that, algebraically, is to divide both the top and bottom by n. Now, that is totally legit, right, guys? You can do the same thing on the top and the bottom of a fraction, right? As long as it's equal opportunity, like, of course, equal opportunity, as long as you're doing the same thing to both of them. So let's go ahead and take every term on the top and divide by n, and every term on the bottom, which there's only one, and divide by n. So the top is going to become a 2n over n plus 8 over n, and then over an n over n. Now, a lot of that cleans up, right? Like, cleans up super nice. The first one's going to just be a 2 because the n's right here would cancel each other. This 8 over n is going to stay an 8 over n, and then these n's are going to cancel with each other, and you get a 1 on the bottom. Now, let's think about this as n approaches infinity. Okay, what is going to happen? So we're going to use the proper notation. Guys, we have talked about multiple times that, and proper notation is very important. And so we're going to get used to it, okay? So this says the limit as n approaches infinity of now our quantity, which is 2 plus 8 over n over 1. Okay, now this guy right here, this guy is going to go to 0. 8 divided by huge numbers is basically 0, so it's gone. And all that you're left with is a 2 over 1, which is just 2. Folks, the limit of this sequence is 2. If I were to plug in a bunch of numbers, eventually it would just basically look like it was 2. Done, the end. Okay, let's try this one. So this one's a teeny bit different. I feel like, ooh, look at that. I have raised these powers, the n to like a different power. So this says n squared plus 5 over 3n squared. So this time, I don't think I'm going to not multiply. Seriously, Mrs. Blocks, totally the wrong thing. I'm not going to multiply by n. I'm going to divide by n squared. Okay, so we are going to divide by n squared. So I'm going to take every term and divide by n squared. That gets me an n squared over an n squared plus a 5 over an n squared. And then on the denominator, a 3n squared over an n squared. Now, check out all of the things that can cancel, guys. These two right here are going to cancel and be 1. These two right here are going to cancel, and there's just going to be a 3 left over. And so now we're going to write the limit as n approaches infinity of 1 plus 5 over n squared all over 3. Okay, now on the previous example, we had this guy right here that said 8 over n goes to 0. What do you think 5 over n squared is going to go to? Like totally 0. Okay, we have even bigger numbers on the bottom. So that is 100% also going to 0. We just get a 1 plus 0 over 3, which, guys, turns out to be a 1/3, and that is the answer to the question. So here's the deal. You can do as much of this writing as you want to. Let's say let's go back up to part A right here. And let me switch colors so I can kind of show you like a thing to do. So if you want to start with this guy right here and you just want to go straight to this guy right here, like I'm totally okay with that. Like if you know and you don't have to do this mathematics in the middle, like this step right here, if you can do it without doing that step, more power to you. Please do that, okay? I would love to see that happen where you just know the mathematics and then you can just jump it right into the limit. So that would be a very cool thing for you to be able to do. Mrs. Fox, I don't feel like I'm ready for that yet. Then don't do it. Just make sure that you're doing the procedures to get the right question. Okay, so let's talk about some vocabulary, right? It is always good to have some vocabulary. And so this says, as a sequence gets closer to a number L, okay, as n increases without bound, then what this means is that the sequence is converging, okay? The sequence is said to converge, and we call it a convergent sequence. So if you're going in towards a number. Now, the last two examples that we just did, both of them had a number answer, so we would have called both of those convergent sequences. Now, what if it does not go to a particular number? And we haven't even done one of those yet. But if it doesn't go to a particular number, like maybe it goes to infinity, like it gets really big, or it's not actually going to a target number, we're going to do some examples in a second, then we say that the sequence diverges. Okay, it is a divergent sequence. Now, no, we're not talking about, I know you've been binge watching like a lot of movies lately. Like, yeah, no, not like the movie series Divergent. No. We're talking about a sequence being divergent. Okay, so if it does diverge, it actually can do so by a couple of different ways. One of them is that it keeps just getting bigger and bigger and bigger. So maybe that like the numbers just keep getting larger and the numbers aren't actually getting smaller. So that's one way to diverge. Another one is by oscillating. So like, what do you mean by oscillating? So maybe like you end up plugging numbers in and it goes from like a positive number, then to a negative number, then to a positive number. And those numbers are not like targeting in on anything. They're just kind of like bouncing back and forth. That's like another way that you can say that a sequence is divergent. Let's do some of these examples, okay? So this says find the first 5 terms and then decide if the sequence converges or diverges. So we're going to use a little bit of logic. Guys, there's lots of different techniques in this lesson today. And it's not like there's one technique to do every single converge or diverge question. You have to like use your brain a little bit and do like an analysis. Like, what should I do on this one? Should I do the dividing thing like I did on the previous examples in example 1? Should I list some terms? So we're trying to do all these different kinds because, you know, honestly, I should give you lots of tools, right? And if I give you lots of tools, then you're like armed, right? You're armed to the best and you can make the best decision. So this first one right here, for example, 2 part A says A sub n is rad n. So let's plug in the numbers of 1, 2, 3, 4, and 5, just like they asked us to, and write out some of these terms. So the first term it says is a 1 because the square root of 1 and 1 is 1. And then we have rad 2, and then we have rad 3. Rad 4 is actually 2, and then we have rad 5. So if you look at these numbers, I say to myself, you know what I'm thinking about these numbers? I think they're just getting larger. They're getting larger and larger and larger and larger. Now, I don't exactly like, some of them are nice, some of them are not nice, but they are getting bigger. Imagine if you put like a 10 in there or a 100. Okay, the square root of 100 is 10. But then what if you put 144 in there? Square root of 144 is 12. Ooh, these numbers definitely are getting bigger. Therefore, this guy diverges. So it's getting larger, and so diverging is the answer. Just like that. Okay, that was super nice, wasn't it? Like super cool. All right, let's do part B of this question. Part B says B sub n is n to the third plus 1 over 2n. I had a sneeze. Excuse me. Sorry about that. Over 2n squared minus n. Okay, so I guess I'm just going to have to plug in some of these numbers and see what happens. So I'm just going to kind of like do the math for you. You're kind of welcome. If I plugged in 1, I actually get a 2 first. It's a 2 on top and then actually a 1 on the bottom. And so that's the first number. If I plug in 2 for the next number, the top number actually is a 9 and the bottom number is a 6. I could simplify that, but I'm just going to let it be. If I plugged in 3, I actually get a 28 over a 15. Okay, that second number I could put as a decimal is about 1.5. This one is a 1.87-ish. Okay, let's just do the next number. It's a 65 over a 28. And now I've gone to more than double. The numerator is bigger than the denominator, so that's about a 2.3-ish. And then the next one's 126 over 45. That's now verging upwards almost of 3 times bigger. Folks, what do you think about these numbers? Do you think that these numbers are like going towards anything, or are they just kind of like getting larger? And guess what? They are getting larger. So because these numbers are getting larger and larger and larger, it's going to diverge. Now, what's interesting, guys, is I actually could have figured this one out another way. Let me see if I can get, oh, there's my mouse. Okay. You could have also done this. It's nice to have tools, right? You could have also like divided by an n squared on the top and the bottom. And then some of the things would turn into numbers, but then some of them would still be left with an n. And then the n would go to infinity. So just knowing that there is a more than one way to do that question is really cool. Okay. Let's go to another example. So this is example 3, and it says determine whether these converge or diverge. So we're still doing more things. But guys, remember, I'm trying to expose you to all different types of questions. So this one says a sub n is negative 10 to the n power. Okay, so let's plug in some of these numbers. Let's think about it. Let's maybe even plug some in our head. Maybe let's just do a couple of these in our head. If I plugged in 1, I would get a negative 10. But then I would get a positive 100. And then a negative 1,000. Okay, these guys are definitely diverging. Now, why would I say these are diverging? These are like oscillating and then like pulling apart from each other. So the numbers are getting like larger and then crazy, like positives and negatives. So they're going like, woo, like crazy, crazy, crazy apart from each other and getting super, super, super negative and super positives. Let's try this one. This says b to the n. It says 5 to the n. Okay, let's imagine plugging some of these numbers in. So I could plug in a 1 and I would get 5. And then I plug in 2 and get 25. And then I plug in 3 and get 125. Okay, like for sure, these numbers are getting larger and larger and larger. So we're going to say that these guys also diverge. Okay, let's do another example. This says c sub n is 1/4 to the n. Okay, let's think about that. 1/4 to the n. I'm pondering. The first term would be like a 1/4. The next term would be a 1/16. The next term would be a 1/64. You know what I think? I think that the top number is always a 1, but the bottom number keeps getting bigger and bigger and bigger and bigger. You know what that means, guys? This is going to converge. Okay, those numbers are going to get closer and closer and closer to 0. Let's do one more example. D sub n says that we're going to do negative 1/4 to the n. Okay. Let me think about this. The first term would be negative 1/4. Then you would have positive 1/16. Then you would have negative 1/64. What's happening to these numbers? So I feel like they're still getting like smaller, but it goes one's positive, one's negative. Oh, Mrs. Fox, does this mean like automatically because it's oscillating that it's going to be a divergent series? And the answer is no, which is actually not a want. It's more like a ta-da, because ladies and gentlemen, what this means is that these numbers are actually still targeting in on 0, but they're going positive, negative, but each time they just get a little bit closer and closer and closer to 0. So it's merging in, still getting closer and closer to 0. So this one actually totally converges. So if you were looking at these, every single one of these was a number raised to the n power, a number raised to the n power, number raised to the n power. These are geometric sequences, right? So all of these R's, let's look at the R's and see if you can maybe make like a connection to maybe like make up your own rule for these. The first one said R is negative 10. The next one, R is 5. And both of those diverged. Over here, R was 1/4, and over here, R was negative 1/4, and both of these converged. Okay, let me give you a drum roll to just think about how the rule might work for converging and diverging for a geometric sequence. Here's your drum roll to think. Did you come up with something? Ladies and gentlemen, the pattern is that if R is greater than 1 or even equal to, folks, it's going to diverge. Okay, so that means if R is greater than 1 and it's actually the absolute, whoa, that is not what I was supposed to write. Give me a second. Let me erase that. Okay, it's supposed to be the absolute value of R. So if the absolute value of R is greater than or equal to 1, it is actually going to diverge. If your absolute value of R, because it does not even matter if it's positive or negative, okay, if the absolute value of R is less than or equal to 1, then this baby is going to converge. You might want to just add that to your notes, okay, just as a rule, okay? Super fancy, I know. Okay, let's go to these try on your own questions. So I feel like I want to give you a couple of moments to work on these. I'm going to give you, I don't know, maybe like 4 drum rolls, just as you think. And so let's give you some thinking time and try to figure out if each of these converge or diverge and then why. And again, there's lots and lots and lots and lots of tools that you can use. There's not one way to do any of these questions. You're going to have to think a little bit. So the first guy, let me read them off to you guys so that you can copy them down. Part A says A sub n is equal to rad 9 minus 1 over n. Part B says B sub n is equal to 7. Part C says that C sub n is equal to n cubed plus n plus 4 all over n squared plus 1. Okay, let's do like several drum roll time limits for you guys to think, and I'll just sit here while you guys think. Okay, go ahead. Okay, if you're not done, just pause the video. All right, we're back. Let's see if we can figure out some of these answers. On part A, ladies and gentlemen, okay, you would probably, hopefully, you recognize that that guy right there would go to 0 eventually, right? We're talking about the limit as n approaches infinity. So if that guy goes to 0 right there, really all you're left with is the square root of 9, which is 3. Folks, that means that that's the target number it's going to, and part A officially converges. It is a convergent sequence. So great. Let's try part B, okay? Part B says it's just 7. Where's the n, Mrs. Fox? There is no n. So if I were to like write out some of these terms, it goes like this: 7, 7, 7, 7. Folks, the target number is 7. Of course it is. That one is actually a convergent sequence. Like, who knew? Okay, this third one right here, I think probably what I would have done is divided the top and the bottom by an n squared and tried to clean it up a little bit. What this means I would get is this beautiful guy right here. Now, I might have skipped that step and gone to maybe a different step, okay? But basically every single one of these, the first one, it just turns into like an N. So I may have, this is going to be hard for me to write, guys, but it would have been an N. And then I would have had plus a 1 over N once I simplified. The next one would have been a 4 over N squared. Yeah, let me see if I can make that happen. Okay, so 4, excuse the crazy writing, over an N squared. And then we would have had the entire thing over. Okay, there is a binomial on the bottom. It would have been of 1, and then it would have been a 1 over n squared. So maybe I would have cleaned it up just a teensy little bit like this, and then thought to myself, what would each of these guys go to, right? So anything that has an n on the bottom is going to go to 0. So this one's going to go, whoops, sorry about that, guys. This one's going to go away. That one's going to go away. That one's going to go away. And all you have left with is basically an n over 1. Okay, now let's think about this. As n approaches infinity and you just have n, basically that's what it boils down to, right? Just an n value. Those numbers, because n is going to infinity, the numbers are going to go to infinity. So ladies and gentlemen, everything would go away except for the n, and we would have to say that it goes to infinity because the n went to infinity and it is divergent. Ladies and gents, that's the end of our lesson today. Wasn't that an amazing lesson? So this is your homework assignment. Here's our funny little like meme slash little thing today. Instead of the Fibonacci sequence, they're Fibonaccios. Isn't that hilarious? Oh, I love these memes. They're so hilarious. Oh, we have a helicopter passing over right now. Let's all wave to the helicopter. Hi, helicopter. Stay safe. Did you wave? I mean, I hope so. Of course you waved. Duh. Okay, ladies and gentlemen, that will be the end of our lesson. Go ahead. Let's get back so you can see my cute face. Just kidding. I know, my silly face. Here we go. I hope that you have an amazing time doing your homework. Just remember, anytime you're having questions, guys, please, please, please come visit me during the office hours. Hopefully you're being successful. You're keeping up with your work. If not, I've been checking in on you. So make sure you're doing your stuff. So I will send us out with our fanfare song, and I hope you have a lovely rest of your day. Bye, guys.